Hello, good morning everyone. So in the last class, we had a discussion about hashing. So we have talked about the static hashing. We have seen hash file organization. We have seen ideal properties those we should have for the hash function, and we listed the properties as uniformity and the randomness of the function. So hash function that we are going to select should be uniform and random. So we have seen the examples of these concepts. Further, we mentioned that there is a possibility that we may have the bucket overflows. We have seen the reasons why we may face the problem of bucket overflows and what is the possible solution. We have seen the concept of overflow chaining, wherein if any overflow bucket gets added into our hash structure, then these overflow buckets are chained together using a linked list. So we have seen the concept of closed hashing. Now, today we are going to extend our discussion related to hashing, and we are going to see how the hash indices are being created. In the last class, we have seen how the files are being organized by making use of hash functions. So today we'll be going to discuss how hash index is being created. So as I stated, hashing can be used for file organization as well as for indexing purpose. So hash index organizes the search keys with their associated record pointers into a hash file structure. Usually, the hash indices are generated as the secondary indices. And there is a reason for that. So if the file itself is organized using hashing mechanism, then a separate primary hash index on the same file which is also organized using hashing does not make sense using the same search key, I mean. So if the file itself is organized using hashing, there is no need to once again create a separate primary hash index on the file with the same search key, right? But instead, it is more beneficial to create the hash index as the secondary index, meaning the file is organized by making use of hash organization based on a certain key value, and the hash index is being generated by making use of some other search key value. So typically, the hash indices are always the secondary indices because there is no need to generate the hash index on the primary search key. So let us see one example of hash index. So see here, we are having this instructor table, right? And this instructor table is organized with respect to department name. So see here, the records are ordered according to department name. Now, for this instructor file, we are creating the hash index. As I stated, we are creating the hash index, which is secondary index. What we mean by secondary index? The order in which the file is stored and the order in which we are creating the index. Both are depending on two different attributes. So in instructor relation, the file is organized in order according to department name, and now we are creating our hash index based on attribute ID. So hash index we are creating based on attribute ID, and here the instructor table is organized as per department name, and that is why this hash index is secondary index. Now see here how we have organized or how we have created this index, hash index, for attribute ID as the search key. So hash function that is used here is sum of digits in ID mod 8. Why mod 8? Because we are having the assumption. So number of buckets that we have are 8. And the hash function that we are using is, we are creating the index on ID. So hash function is sum of the digits in ID mod 8. 8 is number of buckets, right? So say for example, if I am having the search key value, see here this first search key value, first ID. So 76766 is the ID. That is my search key value. Okay, so I am computing the hash for this search key value. So h of this search key value is computed as sum of digits. So 7 plus 6 plus 7 plus 6 plus 6 mod 8, and this comes out to be 0. So what it indicates? It indicates that this search key value will go in bucket 0 of my index. So see here, this bucket 0 contains this ID 76766. Similarly, if I go for the second record, say 10101 is the search key value for this second record, right? So once again, what I'll do, I will sum up 1 plus 0 plus 1 plus 0 plus 1. So it comes out to be 3 mod 8. Right? 3 mod 8 will be equal to 3. So this record having ID 10101 will be placed, or not record, this index search key will be placed in bucket 3. Right? So this is now our index. And in this index, what we have? The search key value along with the pointer. So in my index, this search key 76766 is placed in bucket number 0 along with its pointer. So this pointer is now pointing to this record. 10101 is the second search key value. So this search key is placed in bucket number 3, and along with this 10101 we are having this pointer that is pointing to that particular record, right? See here, whenever, right now for simplicity we are assuming that in every bucket we can store only 2 entries. In reality we may store many number of entries, but for demonstration we are assuming that there are only 2 entries possible in one bucket. So see here, this bucket number 5. So whenever this bucket gets full, then what we are going to do is we are going to add the overflow bucket. So this is my overflow bucket, and in this overflow bucket, rest of the entries, search keys will go, right? And these 2 buckets are chained or linked to one another, right? So this is how we are creating the hash index. So essentially, you should understand that hash index typically is the secondary index. So my relation is ordered according to some attribute, and my index is created with respect to some other attribute. Right? In hash index, we are storing the search key values along with the pointers. And to store those search key values, we are using the hash function, and the hash function is producing some number, and that number is actually the bucket number where we are putting that search key. Right? Now, how I am making use of this hash index to search a particular record. Suppose I want to search the record, say, with ID 22222. So search the record in the instructor table with ID equal to 22222. So what we will do, if I want to search this record in my instructor table, I'll be referring to the hash index associated. Right? I'm not going to search for this ID sequentially in my instructor table. What I will do, I will search this ID in my index. Right? So, how I'm going to do that? I want to search for the record with ID 22222. So, I'll be applying the hash function for this ID. So, I'll be applying hash function on this 22222. So, what we will get out of this? So, this hash function is calculated as 2 plus 2 plus 2 plus 2 plus 2 mod 8. Right? So, what is the solution for this? This is 10 mod 8. So, 10 mod 8 will provide me the value 2. So, what I'll do, I will go to bucket number 2. And in this bucket number 2, I'll search for this ID 22222. So, in this bucket only. So, I'm trying to minimize my search. So, I'll directly jump to bucket number 2 because hash function is giving me that address. So, I'll jump to this bucket, and in this bucket, I'll search for this ID. So, whenever I find this ID, I'll follow the respective pointer, and this pointer will take me to the record that I wanted. Right? Any doubts so far? Yes? Any doubts so far?
No, ma'am.
So I hope you must have understood this concept of hash index. May I proceed?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Right. So let's go to some of the disadvantages of static hashing. So far, whatever we discussed regarding hash file organization or hash index, we were talking about static hashing, meaning in advance we have decided the number of buckets wherein we are storing the data. Maybe it is file or maybe it is index, right? So if the number of buckets are selected in advance, if the number of buckets are fixed, then it is known as static hashing. So if we are having this static hashing, then we may face some problems. So we are going to list out those limitations of static hashing now. In static hashing, function h that we are using maps the search key values to a fixed set of bucket addresses. So number of buckets are fixed. So many times it happens that databases grow with time. So if I have created my hash structure today with the limited data that is available today, then accordingly I might have select the number of buckets. But always database grows as time passes. So database grows with time, and if initially the number of buckets allocated are too small, then the performance of my system will degrade. And the reason is, as initial count of buckets is too small, I need to add many overflow buckets. And if I'm adding many overflow buckets, then definitely the performance will degrade. Right? So that is the very first disadvantage of having static hashing. Next is, if file size at some point in future is anticipated. What we mean by that? Suppose today I am creating the index, or today I am organizing the file using hashing. So today I may predict the size of my database at some point in future, and accordingly considering or predicting some file size at some point in the future, I may decide the number of buckets, and I may allocate those many number of buckets to store my data. But initially my data is very small, right? So in those initial phases, the significant amount of space will be wasted, right? Because I'm not having that much data to store. Okay, so that is one more disadvantage. If I select too many buckets initially, then significant amount of space will be wasted. Now, if initially I have allocated lots of buckets, and suppose I have stored lots of data into those buckets, but sometimes it may happen that in certain situations my database shrinks. That means I'm deleting lots of data from my database, and the size of the database is now reducing. So once again, in this scenario, the number of buckets initially allocated, that number is too big, and now I'm having the data that I'm actually storing is very small. So once again, in this situation also, I'll face the problem that the space is wasted. So what is the solution for all those problems, those we have listed? The possible solution might be periodic reorganization of the file with a new hash function. I'll repeat, the solution that we may think of is periodic reorganization of the file with a new hash function, right? But this solution proves to be very expensive, right? And that is why we need to think of something else other than static hashing. So to avoid the problems those we have listed with respect to static hashing, what we can do is we can make use of a technique that allows us to add the buckets as and when needed. So number of buckets can be modified dynamically. So whenever there is a need, we may add a new bucket, and wherever there is no need, we may remove the buckets. So it is possible using such techniques to dynamically allocate the buckets those are required. So you may compare these concepts with the data structure concepts like arrays and linked lists. So arrays always are having some fixed size, whereas in linked list you may add the nodes whenever required. and you may remove the nodes whenever you do not require those nodes. So similar kind of concept is reflected over here. Right? So I hope you must have understood the drawbacks of static hashing, and we are proposing now a solution for this static hashing, and that is dynamic hashing.